Alright. So, um, cool. So, of course, we are talking about series for this video. For the past videos, we were talking about sequences. Yeah. So, and of course, like when you have a sequence, say for example, it's an arithmetic, we are adding the same value to get the next term. It's a geometric, we are multiplying by the same value to get the next term. It's a geometry, it's a quadratic. It has, yeah, I don't know how to like just simply, say what a quadratic is, but yeah, quadratic, you have a quadratic sequence, which I would say maybe for it, you have the second difference, which is a common difference, and the first difference is a linear or arithmetic sequence. Cool. So now moving from sequences to series is here's the difference. A sequence, it gives us a pattern. Okay, this is a pattern at which these numbers grow or decrease, right? But now for a series, we then take each of those numbers that makes that particular pattern and we add them together. Yeah, basically. So and then for that we have finite oh my word, we have finite series and we have infinite series, right? So for the finite one, you are adding up until a particular term, up until a particular term. Usually for when they say Sn is the sum of the first n terms in the sequence. Therefore, if I'm saying here give me S6, I'm saying give me the sum of the first six terms in our sequence. All right. Oh wow. So 6 here. So if I say in 6, I'm saying give me 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 36. So that is term 1, term 2, term 3, term 4, term 5, term 6, right? So the answer to this, whatever that answer is going to be, you add all these numbers and you're going to get your number, right? Which is 30, which is S6, right? Sum of the first six terms. For the infinite one, we're adding up until like infinity, right? Like we are not adding up until a particular point, we are adding until, right? So it's summation to infinity, right? So this will be, yeah, summation to infinity. That's how we have S and the infinity sign, right? So we are just adding, bro. We are just adding, right? Yeah. So let's go cook something. Yeah. So while we are still talking about series, which we know now, like if we talk about a series we are adding, right? We can talk about this thing we call what? Sigma notation. Ne? Sigma notation, basically it's just one rule for summation, right? And this is what it looks like. This is what sigma notation looks like. And the thing is now with sigma notation, right? So let me make the screen big. So this number here, right, I would say is the last term. That is the last term. And by the last term, what am I saying? I'm saying it is the value that we are going to add up to. Now, if I have 10 there, it means we are adding up until n equals to 10, right? And then this one, right, it's the initial term, right? In a sense of, is the term that we're going to start with, né? Is the term we're going to start with. If it's 2, we are adding from second term, right? So, and then here, right, here you would have your general rule, right? This will be your general rule, which defines a particular pattern or sequence. You see, we have a good example here, right? We have a good example here. So here we're going to add from 1, né? We're going to add from n equals to 1 to n equals to 6, right? So therefore, when we substitute here, we are adding 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5 plus 2 to the power of 6. You see, so we are basically adding from where? We are starting from t equals to 1, n equals to 1 to n equals to 6. This is the 1 and this is the 6, and this is the general rule that defines a pattern that we possibly have. So you put this in a calculator, bro, you get the answer. That is the answer we're looking for here. All right, that's the answer we're looking for here. We have something similar here, something nice, and here you can tell it's a arithmetic sequence, no? So what are we saying for this one? We are starting from n equals to 2, ne, to n equals to 5. So how will we do it then? We're gonna I'll open a couple of brackets. So this is n, we substitute 2 minus 2, right? That's the first one. And then we go again, add, where we substitute 3 minus 2, where we substitute 4 minus 2, and where we substitute 5 minus 2. Right? So you add all of these things, all of these values, ne? You add all these values. Let me just say. So you have this is our 4 brackets. I would start here. 3 times 2 minus 2, right? We go 3 times 3 minus 2. We go 3 times 4 minus 2. The last one, 3 multiplied by 5 minus 2, right? And we get the value 34. Now I want to show you something. We do have it in our calculator, ne? I think shift, yes, there we go. So here we have 5, we have 2, and then here I'll just say 3 alpha x. Here when I say alpha minus 2, we're getting 34. Yeah, so we do have it in our calculator, let me say. But on the questions you have, actually I don't know. I was gonna say on the question that you guys are giving, you're not expected to use a calculator, but we will check that when we get to the question papers. We'll check that when we get to the question papers. But basically this is it, and we can even test. Let's test for this one. And so I'll do it manually. First you have 2 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5, then 2 to the power of 6, right? I am getting 126. Therefore here I go shift, it's 2 to the power of alpha x, and then it's 6. This is 1, and I have 126. Do you see it, guys? Do you see it? So this is it. Let's see for this example. Okay. So we have to write this right in a sigma notation, but before we do that, we know there's gonna be that sign first, right, with I equals to the first term where we're starting and the last term here, right? And then here you have the general rule. I would say yeah, first term and then last term, and then your general rule. So first thing first, you have to discover what kind of a pattern this is. Once you have found the pattern, you find the general formula, and then you're good to go, right? So let's create some space. Cool. So I'm gonna write it first as a pattern, and it doesn't seem like it's a geometric. So yeah, I'm gonna start with the subtractions. I have 7 7, actually minus 7 here as well. I have minus 7 and minus 7 too. Yeah, so I am seeing that I have therefore Tn equals to A plus n minus 1 d. This is the formula I will use. I have 31 here plus n minus 1, then this is minus 7. Therefore I have minus 7 and plus, this is going now to be plus 7 plus 31, right? So I have minus 7 and plus 30 38. Yeah, so let me just test it for 1 2 3. I'll test it for term number 4. If it works, we use it. Minus 7 times 4 plus 38, it's 10, so it works. Yeah, so yeah, now I want to do this. 31 plus 24 plus 17 plus 10 plus 3. The answer there is 85, right? 85, 50, 60, 70. Yeah, 85 makes sense. Right, so now I am done, right? Literally, guys, I am done. So what then is left is for me to say, therefore I'm gonna have something like this, my sigma notation, and I'm starting where n equals to 1 to where n equals to 1 2 3 4 5, right? And then the term 7n 7n, come on bro, 7n plus 38, right? Which it must give me 85. Let's test it. You see, exactly 85. So this thing works, man. Let's see the next problems we have. So here we know the answer. We are looking for this value, right? So it's very easy, bro. Don't overthink it, man. So first thing first, you're gonna expand this whole thing, right? Because you know you're gonna have a multiplied by 2 to the power, we're starting at 1 minus 1 plus a multiplied by 2 to the power of k. Now k becomes 2 minus 1 plus, and plus a multiplied by 2. Right here you will have 3 minus 1, and that's up until, like, this is where we stop. 28. Yeah, that's where we're going to stop. So you have 2, no, you have a to the power of a multiplied by 2 to the power of 0. I'm just not gonna write it because 2 to the power of 0 is 1, anything to the power of 0 is 1, and we are multiplying, so it doesn't make any difference here. Plus this is going to be 2, so you have 2a here, plus here this is 2 squared, so 4, you have 4a 3 minus 1 is 2, so 2 to the power of 2 is 4. Yeah, so you still have your 28. Then we add these values, right? You have 6, you have 7, so you have 7a equals 28. Therefore a equals to, I think, 4, right? So 28 divided by 4 is 7. So yeah, so 4, a is 4. And let's take the second one. The second one, same logic. Yeah, on the same logic, you're gonna substitute j from 1 to 4. So you have 2 to the power of minus 1 plus 2 to the power of minus 2, 2 to the power of minus 3 plus 2 to the power of minus 4. Yeah, well, this one you can just press the calculator and you get the answer. It's, yeah. Yeah. Let me see. Yeah. There's no point in me trying to do it by head. You can just press the calculator and you get the answer. Né? What we can make, let's make it interesting. Let's make it interesting. Let's make it interesting. Hey, what's happening? So the answer happens to be 15 over 16, right? So I can then say, right, I can then say 15 over 16 just to make it interesting, right? And then perhaps here I'll have no, it doesn't make sense. What I was gonna do, yeah, what I was gonna do doesn't make sense. But basically, guys, this is it, man. This is it. You don't have to stress about this thing. It's way too easy. And if it's not way too easy, I'm gonna help you make it way too easy. But for now, let's close it here, and I'll see you in the next video.